Alright, today we're going to look at grouped data. Grouped data means it's not written out in a straight line like the way you're used to seeing it from 8th grade. We group it together. So in the example below, we went to some 6th grade class and we interviewed them. How many pets do you own? Well, we just kept a tally. Notice first of all in this chart that the lowest is down here at the bottom and the highest is at the top. So this simply says that 7 kids said they had no pets. 14 kids said they had 1 pet, etc., etc. Now, if we were to do this the old-fashioned way to find the mean, median, and the mode, well, look what we'd have to do. We'd have to do 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then we'd have to do 14 ones. 1, 2, 3, 4, 5. Oh no, that takes way too much time. So instead, we can do the crossing off for median, just as simple. So I'm going to skip mean for a second here. And like I said, go right to median. Median means start with the low. I have 7 lows. I have to cross 7 lows off with 7 highs. Well, here are 2 highs. Plus 1 more make 3 highs. Plus 3 more make 6 highs. So I'm going to take 1 out of here, leaving me with 4. So there, 7 numbers up top were crossed off with 7 on the bottom. But now, if I have to cross 14 off from the bottom, I don't have 14 left on the top. Well, that tells you where your median's going to be. I can only cross off 12 from the top and 12 from the bottom, leaving me 2 here. So this is where my median is going to be. Finding the mode is very simple. Much simpler with grouped data because we don't have to count. Somebody else has done the counting for us, and obviously the mode here is 1. That's where the most amount of pets are. The mean, unfortunately, is the old-fashioned way. Or is it? We can do 6 times 2 plus 5 times 1 is 5. And why am I doing this? Because I have to count up how many pets there are. See, one kid, he said he has 5 pets. 3 kids said they have 4 pets. So that's 12 pets. Plus 15. You get what I'm doing. Plus 16. Plus 14. Plus nothing. It means we had a total of 74 pets. And we still have to divide by how many kids we surveyed. And if we add this up real quick, 3, 6, 11, 11 and 8 is 19, 19 and 7 is 26, 26 and 14 is 40. So we have 40 kids. 74 divided by 40 means each kid had an average of 1.85 pets. A little freaky, but that's what an average does to you. Now, percentile is a word that you've heard a lot. In fact, when you got your PSAT scores back, you were graded as a percentile. A percentile compares you to everybody below you. So if you scored in the 80th percentile for something, that means you scored better than 80% of the kids who took that test. So you're going to learn today how to figure out a percentile. So we're finding the percentile here, as the question says, of kids who have 4 pets. How do they compare to the rest of this class that was surveyed? Well, we add up the scores below the given score. So here we are at 4. How many were below 4? 5, 8, 14, 7. That's 21 and 13. It's 34. Divided, now we have to add on half of 3, 1.5. And that gets divided by the fact that we had 40. So 35.5 divided by 40 is 88.75%. You are in the 89th percentile for pets. That means 89% were below you. So you had more pets than 89% of the people surveyed. All right, we're not going to go through this, but it's a different way to group data. We group them by intervals. So this is based on how many hours of music somebody's listened to. And notice that it's not a single response, but we said, okay, anybody who listened to 21 to 25, we grouped them together. Well, how would you find the average? What you would have to do is take the average of the group. So between 21 to 25, the average is 23. Between 16 to 20, the average is 18. Between 11 and 15 is 4 hours, so what's half of 4, 2? That's where I'm getting these averages from. Or you could do the old-fashioned way. 6 plus 10 is 16, divided by 2 is 8. Those are the numbers we do to find the mean. And then, of course, we have to multiply them by their frequency. Add that all up, I believe it's 307, and divide by how many we interviewed, 5, 17, 24. So the average number of hours, 307 divided by 24, 12.79. And then we could go through and do the median, the mode, and the percentile the same exact way. Okay, we have one other thing to learn today, and that's about outliers and interquartile range. So below you see the salary of 10 basketball players, and that is in thousands. So in other words, I would have to add on 3 zeros to each one of these to get their true salary. So this guy makes $533,000 a year. And then this guy up here makes $19 million a year. LeBron James, somebody sitting the bench. So I'm going to use my calculator again. And we're going to go to stat mode, and we are going to enter all these, which you can see I have already done. That way, when we let the calculator figure out all our stuff for us. We have, for interquartile range, Q3 minus Q1. And when you do your box and whisker, remember, that's your box. Your box starts at Q1, and then it goes to Q3. This is where at least 50% of your data will be. So if I look on here, my Q1 was 264, and my Q3 was 687. So the range would be, if I subtracted those two numbers, that would be my IQR. 423 is my interquartile range. Now, where does that become important? It becomes important down here when we look for outliers. An outlier is a value that's greater than the upper quartile plus 1.5 times the IQR. A value that's an outlier but on the other end from the lower quartile plus 1.5 times the IQR. So in other words, when we looked at this data, it's kind of obvious that I have an outlier. This guy up here. In fact, if I were to do a box and whisker, my goodness, look at this box and whisker. I have, again, most of my guys down here, And then all of a sudden, he's definitely an outlier. We can prove it mathematically why he is an outlier. We can just come back here and do the math. A value that is greater than the upper quartile, well, obviously this guy was in the upper, so we're going to take the upper quartile, which is quartile 3. So I take 687 and I add on 1.5 times the inner quartile range. If I do that math, 687 plus 1.5 times 423, this tells me that anybody who's above 1,321.5 is an outlier. In other words, their data is going to get thrown out because it shifts so much different than everybody else. And you, living in the Hamptons, you live in a valley of outliers. Think about how many mansions are worth more than $20 million. You're going to yourself a lot, but not nearly as many as how many your houses are just worth $1 to $2 million in Sag Harbor. So you've got a lot of outliers. Likewise, we can find lower outliers by doing the same thing. We would take the lower quartile, which is 264, and minus 1.5 times the inner quartile range. And in this case, it would have brought us into the negative zone. So there are no outliers on the lower end.